So this is 1990 question 11. We're having a body of mass 10 kg. The mass of the body is 10 kilogram. Mass is 10 kilogram. Let's go. So rest on a rough inclined plane. Okay, maybe we have an inclined plane like this. So the inclined plane is rough, which means there will be higher friction on it. Okay, so this is a body that rests on a rough inclined plane. Okay, whose angle is variable. The angle theta of the what of this inclined plane is variable. That is, it's changing. Maybe it's from 0, they are now increasing it to 10, 20, 30, 40. Is variable. That it is changing. This gradually increases until the body starts to slide down the plane at 30. They are now increasing the angle until you reach one angle theta, angle 30 degree, when the body starts to slide down. So at angle 30, the body is about to fall down, which means as you are increasing the angle, maybe it was like this before, you understand? Later it was like this. Later it was like this. You can see. So it will try before it is not falling because the applied force is less to the what? Limiting frictional force, right? So now you have reached the maximum, the limit frictional force that the rough surface have. What will happen to the body? It will tends to fall down. So if it tends to fall down, what will happen then? What will happen is that we'll be having an applied force P, which is known as what? W sine theta. Because I told you guys in the previous video, some of our videos, that anybody at a certain angle, its weight will split into two. Its weight will split into reaction, which is what? W cos theta. And part of its weight will fall we make it to fall down, which is W sine what? Sine theta. So there will be friction opposing this thing not to fall down, frictional force F, right? So let's go. What is the formula for coefficient of static friction? Formula on this program. Don't forget our formula for coefficient of static friction equal to the ratio of limiting frictional force to the reaction. Right? Ratio of limiting frictional force to the reaction. And don't forget, if the body is static, not moving, our limiting frictional force is the same thing as applied force. So we can replace this thing, apply force over reaction. Since the body is just about to move, it has not moved. So it's about to move, which means it has the applied force, the weight that wants it to fall down, which acts as applied force, W sine theta, is equal to the limiting frictional force. So we can replace it in this way by saying the coefficient of static friction equal to our applied force W sine theta over what is our reaction? W cos theta. So coefficient of static friction is the same thing as what is W sine theta? W means weight, and W equal to what? Mass times acceleration due to gravity. What is our mass? 10. What is acceleration due to gravity? 10 meters per second. 10 times 10, 100. It's the same thing as what? 100 sine 30 over 100 cos 30. 100 cancel 100, right? Coefficient of static friction will be equal to sine 30 over cos 30. Sine over cos. Sine theta over cos theta in mathematics. Anything sine theta over cos theta in mathematics means what? Tan theta, right? So we can quickly say our coefficient of static friction equal to what? Tan 30. And 30, tan 30 will give us tan 30 give us what? 0.58. So if you try it, this is what we get on your calculator. This is what we get. So 0.58, which is our answer. So tan 30, 0.58 is our answer, which is tan 30.